So let's have the second example. The second example is this, okay? So you have this circuit, which is you have this time X, Y, Z, P. You have 4 inputs. So this is the circuit configuration. So the question is, what is the basic function of this circuit? Or you could say whatever we have here. Analyze the following combination circuit and evaluate the output as a function of the inputs. Or same thing, find what is the basic function of the circuit, okay? So I give you a few minutes and see, could you actually do that? Could you actually analyze the circuit that we have here or not? So whenever you are doing that, let I actually draw the circuit again here. So we have actually the 2 XOR, right? So one is here. The second one is here. And the third one is here. So whatever you have as an input is just X and Y. The input for the second XOR is Z and P. Okay. So here you have these 2 outputs connect to the third actually XOR, and you have the label for this. You want to analyze this circuit. If you back to the origin one, which is here, it's already labeled all outputs. So see here, these 2 location that you see here, it's actually labeled T1 and T2. We are doing the same thing. We use actually the same label, okay? So I call the first one T1 and T2, okay? So similar with the previous example, so definitely you know what you need to do, right? You need to find the C, find the actually Boolean function of the main output, which is the C, base of the inputs that you have, X, Y, Z, P. Then use that function, get the truth table. So take a look to the truth table and find a basic function of the circuit, okay? So for doing that, we actually start with this C, right? So you already know this C is the XOR, so we already know the definition of the circuit. So the C should be equal to XOR of T1 and T2. So that means it should be T1, T2 prime plus T again, this time should be T1 prime and T2. Okay, so that definition of the XOR. So, but the problem is you don't know, the C should be based off the real inputs, which is X, Y, Z, and P. So that means you need to replace this T1, T2 based off whatever you have here. So that means I need to find the T1. So T1 again is another XOR based off the X and Y, right? So that means the T1 X Y prime plus X prime Y, right? That's just definition of the XOR, right? The same thing for T2. So T2 is, if you check the T2 here, the input is Z and P, that's XOR. So it should be Z P prime plus again Z prime P. Okay. So far nothing actually new. So what we already know, we need to do that. So then the next step definitely is to replace this T1 with this that you have, XY prime plus X prime Y, and replace T2 with the ZP prime plus Z prime actually P. So let's do that. So first, if I replace T1, so here I actually write the C equal T1 is this, whatever you see here, okay? So I just replace the xy prime plus x prime y. This is T1 times T2. This is T2. You need to use the De Morgan theory 2 times, similar with the previous example. So T2 prime. So whenever you have prime, should be the prime of this and dot prime of this term. What is the prime of this? Again, it should be z prime plus p. What is the prime of this? Should be z plus p prime. So that means you use the De Morgan for 2 times, okay? I do that. So I replace T2 with this, which is should be the prime of this, which is z prime plus p prime prime, which is p. So then you have time, then you have the next one prime, which is should be z prime prime, which is the z plus p prime, okay? So that's it. So that's what we replace for T2, okay? So plus, same thing for T1 prime. So this is T1. So prime should be the prime of this dot prime of this based off the De Morgan theory. What's the prime of this? Again, is another De Morgan. It should be x prime plus y prime prime, which is the y. Same thing. What is the prime of this? It is x prime prime, which is x plus y prime. That's again De Morgan theory. Okay, I do that. So T1 prime should be the prime of the first one, which is x prime plus y prime prime, which is y, dot the prime of the next one. X prime prime is x plus y prime. Okay, so this is T1 prime times T2, which is you already have T2, right? So T2 is just ZP prime plus Z prime P. Okay. Just double check everything that make sure you actually have the right things. We have xy prime plus x prime y, z prime plus p. This is right. So then you have z plus p prime. So here you have x prime plus y, x plus y prime, z p prime, z prime p. That's right. So the next step actually is to make this a little simple. So how we could do that simple. So we actually distribute these two parentheses. Same thing here for this. Okay. So I distribute this inside this. So the z prime should be 0. I'm not going to write that. The next one should be zp. I just replace with zp. The same thing. The next one should be p prime z prime. So z prime p prime. And the next one should be p prime, which is 0. I'm not writing that. Same thing for this. Distribute this inside this. You have x prime, which is 0. So then x prime y prime. So from this you have x prime y prime plus distribute this inside. So it should be xy, then y prime, which is 0. I'm not going to write that, okay? So this is actually is the next step, okay? So what's next? So you consider as a one parenthesis here, one parenthesis here, then you actually multiply whatever you have here times whatever you have here. So the same thing, you say time, distribute these parentheses inside these parentheses that you have, okay? So then I'm writing actually here, C equal. So first, I distribute this inside this. Just be careful, you actually put in order. Your variables should be in the order if they are not. So see, the order is x, y, z, p. If they are not in the order, whenever I distribute, I actually do that. So first term times this, which should be x, y prime. One is zp. Again, you have x, y prime, z prime, p prime. Okay, I just distribute this inside these parentheses. Plus, same thing for the next term. So you have x prime y, z p plus x prime y, z prime p prime times this inside this parenthesis. Same for the other one. Distribute this inside this. So the first one should be x prime, y prime, z p prime plus again x prime y prime. The next sentence, which is z prime p. Okay, plus distribute the next one, which is this. So it should be x y z p prime plus again x y z prime p. So this is this the standard form? You tell me, whatever we got. Yes or no? That's definitely is the standard form because you have the midterm and you have the all variables inside that. So let me just write what's the midterm numbers because we want to get the truth table. Okay, so I start with this, you help me. So what should be these midterm numbers should be what? M, you tell the numbers. So this is definitely is 1, this is 2, this is 4, this is 8. So what should be the number for the first one? M. You could just type on the chat box what should be the number. M. 11, that's right. There should be 8 plus 2 plus 1, which is 11. Definitely is right. How about this? Type it for me. That is actually 8. That's right. So what should be this? It should be this M7. That's right. How about this? What should be this? M4. That's right. What is this? What is this? Help me. M should be 2, right? M2, just Z. Yep. How about this? M1. How about this? Should we just be careful? Should be 14. 8 plus 4 plus 2. Yeah, that's right. That should be 14. How about this? It is 13. That's right. It should be M13. Okay. So I got these standard form. Easily, I should actually get I easily able to get the truth table, right? So we have these truth table. So this time I have 4 input, x, y, z, p. So how many row I should have on the truth table? I have 4 variable. Type it. What should be the number of the row in the truth table whenever you have 4 variables? Should be 16, definitely. So you need to make all that 16. So that means should be 1, 2, 3, 4, 5, 6, 7, 8. And you need 8, 1. 1, 2, 3, 4, 5. I need to go a little up. Yeah, 4. Yeah, 1, 2, 3, 4, 5, 6, 7. Probably more room. Yeah, 8 here. Okay. So just I have to do this because yeah, it's help us to be on the track. Okay, so just separate all of these rows. And just make sure I did right thing. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's right. Okay, so the rest should be easy. So for the next column, you just say 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. So the next should be 2, 2, 0, 2, 1, 2, 0, 2, 1, 2 0 2 1 2 0 2 1. Okay, and the P should be just 0 1 0 1 0 1 0 1 0 1 0 1 0 1 and 0 1. So see, this is the all possible bit pattern that you could make with 4 variables, right? So that you have the all that 16 different bit pattern that you could make whenever you follow these pattern, okay? So what I need here is just one output, which is, we call that C. So we need to go a little up. So start with the which midterm we have. We have 1 and 2. So in 1 should be actually 1. In the 2 should be 1. So what should be the next? 1, 2, we have what we have? We have 4. Yeah, we have 4. Yeah, put here, which is the 4. So what else we have after 4 is should be the 7, right? Where is the 7? 7 is here. I put 1 here on the 7. So what is the next after 7? It should be 8. So this is actually 1 here. I put 8. So after 8, we have 11. So where is the 11? 11 is here. This is 11, right? So this is 11. So what else we have after 11? We have 13 and 14, which we need to move down. 13 and 14. So the 13 and 14. So this should be the 14, right? And this should be 13, okay? So the rest should be just 0. So I put again 0, 0. Okay. So you actually end up with these truth tables. So then again, you take a look to the table and find a specific function for that, right? So here, if we check this, whenever again it is 1, which is odd, it have 1. Here is odd is 1. Here is even is 0. Here is 1 is odd. Here is even is 0. Here is odd. Here is odd. Here is even. Here is even. Here is odd. Here is actually even. Here is odd. Yeah, it is doing exactly the same thing with the previous one, but this time this is actually 4-bit odd parity checker, right? So see this circuit able to check similar with the previous one. Previous one just able to check 3 inputs. If the number of the one inside that tree is odd, it's turn on the LED. So this is do the same thing, but if check 4 bits, okay? So if the number of the one inside that 4 is actually odd number, it's turn on the LED. So that means that is 1. If that's the actually even number, the LED should be off, right? See here, if you could check the couple of, I checked all of them, it works, but you could check a couple of them. For example, here is 0, you have 2, 1, which is the actually even number, right? So here you have these 3 is odd number, you have 1. So here this is 4, 1, so that's actually the even number, you got the 0, okay? So that means here I could actually maybe do the same thing for the previous one. I need to add one more terms here. It is actually 3 bits odd parity checker. So this one and the second one should be actually 4 bits. 4 bits odd parity checker. Okay. So this is actually is how you could analyze the circuit, okay, combinational circuit. So again, you just find the output, the Boolean function of the output base of your real input, which is here is XYZ, get the standard form. So then draw the truth table based off that function and take a look to the truth table and look for a basic function or any other function inside that. Okay.